All right, our week ahead today. Got a little activity for us to do. We'll do 6-4 tomorrow. Pretty simple. Review Thursday or worksheet Thursday. You guys want another quiz?
No.
Yes.
I'm good.
If it's not graded,
Those quizzes that you did last Friday, I have graded. I'm staying late today. I'll put those in the grade book today.
We'll see how our grades do.
8-ish period.
Is Mrs. Wolf's class doing like the 30?
We're doing the same thing in here. Yep. Mrs. Wolf and I agreed that the quizzes were not good. If you have not used your retake for the coming weeks and you choose to retake this quiz, because of the time constraints of the exam and review and setting up retakes and all that, where it's actually it's an assignment that's run through our online book. It's 30 questions. It's some drag and drop proofs. It's some fill in the blank stuff. It's some drop down yes or no, those kind of questions. It's on the topics that you struggled with on the quiz. You can get up to half of the points back, and there's not a cap for what your grade was on the quiz. Like the syllabus says you can get up to a 90%. So for students that got 90 to 100, there's typically no benefit for doing a retake. This is a little difference. It's more of an activity, more of a credit recovery point for points if you choose to do it. You have to have all the homework completed for the sections that were on the last quiz to retake it. Tally.
Was the quiz out of 42 points? Because I want to make sure I'm not looking at the wrong.
45.
45.
I have not entered it in yet.
That's what I
Christiana.
Did anybody get 100%?
Yeah, some people did great.
I couldn't have figured it. I must have.
All right. I'll enter those in. We'll talk about that tomorrow. All right. Exam review starts Friday. Here we go. Here we go, guys. Quiet, please. All right. Let's go. Jared, help us out. A third of 15. Mackenzie, 2/3 of 15.
10.
Chase, a third of 18.
6.
Jackson, a third of 27.
9.
Caden, 2/3 of 27.
18.
Christiana, 2/3 of 21. All right. You're probably wondering why the heck are we doing that today? You're going to see in a little bit. However, let's make a quick little observation. Who can tell me if you're taking the relationship between if you're taking a third of a number and 2/3 of a number? Olivia.
Multiply it by 2.
It's double, right? Obviously, 2/3 is double 1/3. If you have a third of a pie and you're like, no, I want another piece. Now you have 2/3 of the pie. You double the amount you get, right? Double. Or reverse, you would have half of what you had before. If you go from 2/3 of a portion to 1/3 of a portion, keep that in mind for later. All right, homework answers. Check them.
Oh, I probably did the whole.
Have you guys had a chance to check those? Any questions on the homework? Sure.
I only got the X for 7 times.
Oh, I see.
You didn't
8.
even do the whole.
I've scrolled down. There's 8.
29, yes.
Any questions on the homework?
Did I write the wrong problem down in my book?
Page from these evaluation tests.
This is practically a sponge, you know?
I did.
That's how your book thing they do.
I wrote the wrong thing down. I'm such a monster.
Nice.
Yeah.
Made a 16
Sure,
instead
get
of
that
a
done.
13 because
Not
I
really.
was line.
So, that was 10 points off for the day. But I was like, that's what
I look at 29 people.
Oh, I know.
I think that'll work.
I don't know, like, unless I actually don't know. I don't know, like, what's
You don't really talk about it.
Questions on the homework? Any questions on the homework?
All I know is
All right. A couple key terms to fill in on our guided notes that you should have received. A blank of a triangle is a segment from a vertex to the midpoint of the opposite side. Okay, so first of all, let's talk about what this looks like. All right. Do you agree? This is my vertex. If I wanted to go to the midpoint of the opposite side, let's say it's right there. What that segment is called is a median. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So what I've done for us today, I cut out some whiteboard stuff, some triangles. So when I cut them out, I have the vertex, and can you guys see that little tab? I don't know what to call it. What should we call that? Dot. Thank you. All right. If you connect the vertex to the midpoint of the opposite side, that is called a median. All right. So how do you find the midpoint of the opposite side? Well, it depends. If it's on a graph, midpoint formula. Not on a graph, you'd have to measure the length and cut it in half, right? To get the opposite side's midpoint. That's one median. But guess what? There are 3 medians in a triangle. There's the second one. There's the third one. The 3 medians of a triangle are, new word for us, concurrent. Concurrent. The point of concurrency is called the centroid. Okay, so let's break down this vocabulary. Do you think, if I asked you to walk into class today and draw 3 lines, do you think they would all 3 intersect at one point most of the time, almost never, or just some of the time? You think they would intersect at one point most of the time? If I said draw three lines, 1, 2, 3, I bet most people would probably draw segments or lines, something like that. Would you agree? Do these 3 lines meet at one point? No. When they meet at one point, it's called a point of concurrency. Okay, a point of concurrency. That's what we wrote down here. It's called a point of concurrency. This specific point of concurrency has a special name. It's where the medians are concurrent, and it's called the centroid. The centroid. You with me? This triangle is acute. I made it acute. This angle specifically, I made 80 degrees. You're going to get this same triangle. All right. The next triangle we have, I lied. This is the right angle. This is the right triangle. This is the 90-degree angle. This one is the 80. All right, 80. And then this one, pretty obtuse, isn't it? Very obtuse. All right, so I cut out cardboard triangles for you guys. Now, the very interesting fact about the centroid, and this is the biggest application that the centroid has, is that it's called the balance point of the triangle. You guys have that in your notes? I think I put it to the right. Okay, it's the point where the triangle will balance. You guys see that blank there? Kind of hiding. Balance, yeah. So you guys are going to do this part. Now, mine is made out of whiteboard. So I'm not going to be able to put the tip of my pencil on here because it's too slippery. All right. But if I take the point of my eraser, okay, and I put it there, it slid. I need to get rid of the whiteboard is causing it, or the marker is causing it to slide. It's the point where the triangle balances. It's very sensitive, just like some of you. No. If you go off from that center point much at all, it doesn't balance anymore. Okay? So what you guys are going to do with yours, watch, just a little bit off, doesn't balance at all. So that's a balance point of the triangle. It works for obtuse, acute, and right triangles. We're going to talk about some applications. Why would you want to find where a triangle balances? Well, it could be extended into other fields, a lot of engineering applications, not just triangles, but solids, three-dimensional objects. The centroid is also called the balance point. It's just the center of mass instead of the center of a two-dimensional flat object. All right. So I'm going to let you guys branch out into groups. Not based on your seating chart right now, because I know you guys are pretty sensitive about that. Okay, so you're gonna gather for a little bit into small groups. Let's say 4 per group, 4 or less per group. If you notice a straggler somewhere, call them over, have them join your group, and we will walk through the next portion of the activity together. All right. All right, you're gonna send one person up from each group to get one of each type of triangle. One from each group to come up and get a type of each. One of each triangle.
Oh, one in all of us.
One person from each group.
I like this.
Yeah.
I got
Josh. I was gonna like fake throw it and then it fell in my hand.
Who's in your group? Okay, you guys need we need a groups of 4, so you're gonna pair with them. All right, you're also going to need yardsticks to draw in the medians.
Where's a lot of these drawings?
I got it.
Yes, please draw on them.
I found the point.
Out of. Are you guys pairing up? I don't have enough to give, so I need these for the 6th grade class. You guys pairing up, all 4 of you? You can't have groups of 2. Sorry. So 4 of you? Okay, there you go. Yep. So you're gonna take a pencil. Don't use pen.
You're gonna draw in the medians, all three medians on all three triangles. Take turns, let other people draw. Take turns.
There's the other one of it.
Wow. Dude, 1 point.
If your medians don't meet at 1 point, redraw them. And then I will tell you this. If you take the tip of your pencil and poke it through the first layer of cardboard, it should help you balance it. They're so light. Jackson, you're just showing up. Did you draw on your medians?
Yeah.
Nice. You guys draw them?
Yeah.
What was this?
Well, it's hard to like.
I don't even need it.
That makes sense. Thank you.
Really? Yeah.
No, it's hard to hold.
It's not that. How was the Spanish? Yeah. Oh my gosh, I'm magic.
Okay, guys.
So I would.
Oh yeah. Look at that.
I don't know what I got.
Is it? What you doing? Look at these points of concurrency.
I am so. Yeah. Stand up. Ready?
All right. Once you have done all three medians on the triangles you have, let's head back to our seats. Open up our laptops.
Ready?
Stop there.
Where are these?
Thanks. Yardsticks, go back up here.
You can go one though. You didn't give us enough time.
Oh, you're spinning it. I just got
We didn't have time because our lines were messed up.
Yeah.
Oh, that was so good.
Yeah. Oh, this isn't their one. They completely misses
I didn't realize there was like dots. I was just doing stuff.
They explained to us that there were pages.
Yeah, when you tell us the lines have crevices.
You did.
You called them the task.
Crevices? No, dots, little dots. They were on the side. Yes, he did. It's on the.
I love my job. I love my job. I love my job.
Okay.
There we go.
All right, laptops out, please. Laptops out.
Oh, yeah. I just got
Okay, I lost my every person.
Hey, in all fairness, nobody ever told her not to lose it. Okay.
Exactly. Well,
Good point.
doesn't everybody here preface
Oh yeah.
I call them dots.
All right. We're going to do the same thing, only now we're going to figure out some segment relationships within those medians. All right. So before you get too far, freeze for 1 second. When you drew in the medians, and you have your centroid, okay, there are certain segment relationships that are formed by the centroid. Before you do anything, I want you to you guys still have your triangles with you or nearby?
Yeah.
Eyeball it. Here's what I'm talking about. Watch up here. Take one median. Look at it and think. Make a guess. What length relationship do you think it is to go from maybe the midpoint to the centroid, and then from centroid to vertex on the same median? Let me say it again. Length relationship. Like if I were to take a ruler and measure from the midpoint of one side to the centroid, and then from the centroid up to the vertex, what segment relationship, what measurement relationship does it kind of look like between the two? Do you understand? What did you say? I didn't hear what you said.
Oh, I said not congruent.
Not congruent. I agree.
Oh.
Not congruent. Guesses? Guesses? All right. We'll figure. Josh.
So like from the midpoint to the middle, it's like 1/3 the full length.
Okay.
Like the fraction of it, and then like the rest is just 2/3.
Okay.
If that works.
So comparing these two, you would say this is blank of this.
Yeah, kind of.
If this is 1/3, this is 2/3.
I think so.
Maybe this would be half of this.
Mhm.
Is it a third half of
Yeah, that
two?
makes sense.
Okay.
If it was equilateral, would the two things be equal?
What
Or
you think?
no? Like the
Medians?
centroid to the vertex and the
It would not. It would not. The medians would be congruent, but not the segment from the midpoint to the centroid and centroid to the vertex. Those would not be congruent. All right. So you're going to find the guided activity on the weekly agenda. It's that link right there, the guided activity. And here's what it's going to look like. You should get to this page. Sign in or what? Okay. Please type in your name. Please put your name. Don't put something weird like math star, geometry genius.
I really wanted to put that.
Pointy thing on end of midpoint segment. But I never told you what that was called. So, are you guys good? Got 6 people in. I don't think you have to create an account. You just type in your name. Just your first name's fine. We don't want GeoGebra to steal your identity. Are you having issues? Not just in geometry. Everybody there? Ryan, you right?
Okay.
No, I'm not. I'm trying Yes. Oh, Ryan.
Let's did go back to Canada. Click on the guide activity.
Ryan, can I help you?
Yes, please.
All right, the rest of you, if you're there, follow the prompts. Drag the white dots into different locations, and click through the little. I think it's called an applet, or like an interactive activity. Go back. Click on the link again. Sign out. Yeah, not bad. I got you right. Did you read the directions? All right. So I'm going to walk you through the first little part. It says, slide me. Now watch. Everybody freeze. Everybody freeze. I want you to get the intended meaning of this. What do you think it's doing there? Making a midpoint, right? Making midpoints. Now, I put the midpoints on the triangle cutouts for you because I didn't want you to try to like measure with the ruler and take half of it because that probably would have been tedious. I'll put it that way. All right. Then what? Midpoint. Midpoint. Okay. Now what? Yeah, they draw on the median. You see a little tick mark there? Remember that. Remember that. Double tick mark, triple tick mark. Boom, 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 boom. All right. Then go through the guided activity. Answer the prompts. Bless you. Answer the prompts. We'll take a few minutes on this. This is not a like I am not allowed to talk to anyone kind of activity. If you want to work together with the people nearby, that's fine. We're not going to move though because that'll take time.
How can you describe the intersection of triangles 3 medians? Precisely.
There's that question. Just hit the intersection. Guys, what do you say? After like that Friday, I'm gonna go to sleep and I'm gonna wake up.
Try to practice your new vocabulary.
Like, what?
I think it's 12.
No, well, I'm just not gonna like wake up.
Well,
Like, exams are gonna be so rough. Especially, cause like I'm in English. She's not. Mrs. Conway.
I think G is 12. Yeah, GS.
Alright.
Put that up for the next quiz so you guys don't copy.
Oh yes. Like they gotta add the whole. Central. Entire purple is 18. BG. That would what? What do you want? Okay, because that'd be 6, that'd be 6, that'd be 6. That's what I was told. I'm just put BG equals 12. BF equals 6.
On each one. No, what did it do? Numbers of the kids.
You two put together.
Equals 12. That means half of it is like 9.
And they all.
What? Oh, wait. Yeah, okay. This is the 4. Yeah, alright, not gonna question that.
The points What about the points?
Point to the middle.
The median. I don't know.
Only 2/3 of the distance.
Yeah. Wouldn't it just be 2/3? Are you on test 5/4?
This one?
I'm on test 6/5.
6/5. They all two. I just said, that's why I said go 1.5 inches of distance. When you look at the picture, so it goes like in between the one and then 7/5. Oh yeah. Like if I heard this one.
Just relax.
1.5 over 3.
I'm pretty sure you find like a third.
All right.
From the midpoint.
We're going to pause where we are. I want to make sure we don't leave without discussing the actual relationship. So are you able to do the homework assessment or assignment on your own? All right. Let's pause what we're doing. Kind of put your laptops down for a second. All right. Let's discuss. I think the most difficult part of the activity probably would have been finding the relationship, the ratios of the segments. So watch up here. Does everybody see this green median?
Yes.
Green median. What if they told you the length from G to D is 7? What would the length from C to G be? 14. Perfect. So what if they said, what's the ratio of CG to GD? Well, CG is 14 to GD is 7. It's 2 to 1, right? 2. What does that mean? It means this portion of the median right here is double this portion of the median. Can you see that from the tick marks they showed you? Right? See the one tick mark? It takes 1, 2 of those to make up this portion of the median. 2 to 1. But wait a minute. 7 is what portion of the whole median? 1/3. What portion is this part of the median of the whole? 2/3 of the whole thing. Remember the warm up? Remember the bell work? What if I say this blue median, this portion of the median is 20? What's this portion of that median? 10. Very good. Very good. What if I say this purple, the whole median, this whole purple median is 27? What's this portion of the median? 9. And this portion is 18. That is very, very important. That's going to be a big portion of your homework tonight. Okay? So here's the relationship in our notes. We're back to our guided notes. This will wrap up the class for today. Time flies when you're messing with cardboard triangles. Doesn't this look really confusing? AP is 2/3 of AE, BP is 2/3. We just explained, we just figured out the relationship in the medians. Okay? This is the centroid theorem. Anybody have a watch that like has to charge and it dies and you like feel stupid because you keep looking at it even though you know it's dead?
No.
Nobody ever?
I did.
Do you ever feel like you're like, I just looked at it 2 minutes ago and it's still dead? That's me today. Ah. Yeah. All right, I want to get to one example. This is in the book if you need more time to write that down. Now, here's what you need to decide. When you're given a triangle and you're given a portion, you need to decide, is that the 1/3 or 2/3 part? Is it the 1/3 part, the 2/3 part, or is it the whole thing? Well, this is the 2/3 part. Oh, so the part of the median that connects to the vertex is always the 2/3 part. The part that connects to the midpoint is the 1/3 part. All right, let's see what it asks us. It asks us for QW. If SQ is 8, what's QW? 4, very good. And SW is the whole thing. What's SW? 12. Ooh, isn't that easy? It's pretty easy. You just have to decide, am I given the 1/3 part, the 2/3 part, or the whole thing? And go from there. Make sense?
It does make sense.
Awesome, Mr. Parker.
See, if we had a quiz on this, I would pass it.
Yeah, this would 100%.
If we don't add
Like
links on it, we're
today.
literally no
How about we
reason.
have
There's no reason to do that.
All right, we'll do the centroid formula tomorrow. Real quick, let's talk about what is it? Who can raise their hand and tell me what a median is? Christiana. Nope, not in this context. Paige.
Segment from a vertex to the midpoint of the opposite side.
Thank you. Yeah, in other contexts, in data, it is the middle of something. A midpoint. Tessa, what's a midpoint? It's half of a segment. What is a point of concurrency, Josh? Point of concurrency.
It's like the middle. It's like the centroid kind of where all the, what do you call it, medians meet, right?
It's where the medians meet. It's where the 3 lines intersect. Good. So the centroid, he just told us, is where the medians meet, right? We're talking about the centroid formula tomorrow, and we'll talk about some balance point applications. Please write down, listen, before you write down the homework, any of them that ask you to graph the centroid, we're going to skip for tonight. Any that ask you to graph the centroid, we're going to skip for tonight. Please do the other ones. Please put your yardsticks and your cardboard, put the cardboard triangles that have been drawn on in this pile over here to the right. This pile to the right, if they've been drawn on.
I was a new one I thought that helped. We just need to What is the schedule?